Alright, gang. Chapter 5 sample test review so that you can, for all your cramming needs. Let's get my pen ready. Alright. Number 1, 2, and 3 are about writing in standard form, which means all extended out, like terms combined, no parentheses, no factors, just everything expanded out. And, the terms being put in descending order, like the highest power first, and then it kind of goes down from there. And then you're going to classify by degree and by the number of terms. So please be aware that if something has a power of 4, like if its highest power is 4, then we call it a quartic. If the highest power is 3, we call it a cubic. If the highest power is 2, that's quadratic, as you should have experience with already. You should kind of know that already. That if the highest power is squared, power of 2, it's quadratic. If the highest power is just 1, like all you see is an x as the highest power, x to the first, that's called linear. And if it's just a number constant, oddly enough, then that's constant, like technically a power of 0 on the variable x. That'd be called constant. And to classify by number of terms, remember that if there's 3 terms, it's called a trinomial. 2 terms is called a binomial, and 1 term is called a monomial. Anyway, in number 1, what we have to do is simply clear the parentheses, which technically you could distribute. Not much happens because all we're really doing is distributing a plus sign or a plus 1, okay? There's also sort of a plus 1 out there. So there's not really much impactful distributing to do. And really we could just bring all this down without the parentheses at all. And then we look to combine like terms. 2x squared will combine with 3x squared to make it 5x squared. This negative 1x, or negative x, will combine with this positive 7x to become plus 6x, and then that minus 4 doesn't combine with anything, right? And so that's the standard form for that. And so now we just classify it that, well, let's see here. So the highest power is a power of 2, and so we call this quadratic. And there's 1, 2, 3 terms, so we can also classify it as a trinomial. So it's a quadratic trinomial. In this one, again, we have to kind of expand it all out. So this is all kind of factored, but we actually need to multiply all these factors back together. And so really when you have like x plus 2, that whole bubble squared, that means there's 2 factors, 2 bubbles of x plus 2. And now we got to multiply all these bubbles together. And it doesn't matter what order, I suppose, you multiply all these bubbles back together, but why don't we just multiply these first 2 together. A lot of teachers call this FOIL when it's a binomial times a binomial, but we're just going to distribute and get, well, maybe I'll do that in a second. So we get, let's see, x times x is x squared, x times 2 is plus 2x. And now we distribute this 2, okay? 2 times x is 2x. And then 2 times 2 is 4. This will simplify a little bit because these two terms are alike and they combine. And so that's what I get when I multiply these two bubbles together. But there's also this bubble. Now this is kind of an intricate small detail, but so important. I mean, don't forget that we're multiplying all of this to that third bubble, okay? So more multiplying to do. And watch carefully for a second. I mean, we could think of this factor, this bubble, being like over here on the left and distribute that way, but I mean, I'm just going to do this. I'm just going to do, well, I'm going to distribute the x squared to both of these. I'm going to do x squared times x, and then x squared times negative 3. And then I'm going to distribute the 4x, and I'm going to do 4x times x, and then 4x times negative 3. And then I'm going to distribute the 4 times x, 4 times negative 3. So I guess to show all of the arcs in a, well, just with the mouse here, bam, and bam, and then I'm going to do bam, and bam, and then this I'm going to do bam, and bam. So that'll get me x cubed, because x squared times x is x cubed. Oh, whoop. X squared times negative 3 is negative 3x squared. Now 4x times x is 4x squared, and 4x times negative 3 is negative 12x. Now I still got this. 4 times x is plus 4x, and then 4 times negative 3 is negative 12. A little bit of cleanup. Nothing combines with the x cubed, but negative 3x squared and plus 4x squared, that'll be plus 1x squared, plus 1x squared. And then these two combine together. Negative 12x plus 4x is negative 8x, I do believe. And then this term will combine with nothing. But please don't forget about what the directions wanted in total. So this is what we're going to go with for standard form. Remember, this is all expanded out into just like separate terms, and it goes in descending order: power 3, power 2, power 1, and what's technically power 0. But again, like I was saying, the directions also called for the classifying by degree and by number of terms. By degree, this is cubic because of the power 3. By number of terms, 1, 2, 3, 4, well, 1 term is monomial, 2 terms is binomial, 3 terms is trinomial, 4 terms there's no cute name, so you just kind of like, you just, well, generically, I guess you kind of have to say that it's just a polynomial of 4 terms. There's no actual cute name. Number 3. Okay. Once again, you might want to think of it as we're distributing to clear the bubbles away. This is going to actually have a huge impact when you're distributing a minus sign, which is technically a minus 1. There's nothing really out there to distribute, technically a 1, I suppose, but what's that going to do? So that's just going to be 4x cubed. You can just sort of essentially drop the parentheses. But now this, okay, minus to the 4x cubed, a minus to the minus 7x squared, that's going to make it plus 7x squared. Minus to there, this is going to make it a minus 3x, and this minus going here is going to make it a plus 2. Now just, again, combining like terms. So nothing will combine with the 4x cubed, but then this 7x squared, oh wait, I was wrong. I was wrong. Don't get overly, comfortable in habits, I guess. I was caught assuming. Because look, those totally combine, and they combine into 0. 4x cubed and a minus 4x cubed, that's technically 0x cubed. Gone. But then there's this and this. So those combine into a 14x squared. And again, this is standard form we want, so I kind of want to look at this next to kind of go in descending order by degree. So the minus 3x, I don't think there's anything that's going to combine with that. And then we have this minus 2 and this plus 2, which make 0. So that's kind of gone. So now to classify it, we would just have, let's say the power is 2, the highest power is 2, so again that's quadratic, and because there's 2 terms, we could also classify it as a binomial. Alright, number 4, the directions totally change, and now they say we want to write a polynomial function in standard form. Well, I guess they don't totally change, but I guess what they're giving you is a totally different thing, at least. So what they give you is the zeros. So here's what you got to know for number 4. When they tell you that one of the zeros is 1, that means one of the factors is x minus 1. When they tell you one of the zeros is 0, that means one of the factors was, well, could have been, for example, x, and that's what you should that's what you're gonna do. I mean, like if they tell you that one of the zeros was 0, just use x as one of the factors, and if one of the final zeros, was negative 2, then one of the bubble factors that you would set equal to 0. It's almost like, what bubble would you set equal to 0 to get this as an answer? And the bubble, the bubble factor that you would set equal to 0 would be x plus 2. So there's a very, 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 very clear connection between the final zeros / answers / solutions, x-intercepts, whatever you want to call them in whatever situation. There's a very clear connection between zeros and the factors, okay, of the polynomial. Okay, from here, you just have to what? Multiply all these factors together, okay, multiply them all together to come up with the polynomial, okay, polynomial function equation. So I think like a textbook, most textbooks might use p of x or something. I'm just going to use y, so I'm just going to use the y, and I'm going to put the x factor out in front, kind of as like a GCF sort of thing. But I'm going to have to, again, I'm going to have to multiply hold on a second. I'm going to have to multiply all these together, all the factors of the polynomial, to come up with the standard form of the polynomial. So here we go, just setting this up. And what I'm going to do is I'm actually going to foil these two bubbles together first. Is that okay? Well, too bad. So I'm going to foil those two together, and then after I foil these together, distribute these together basically. Then I'm going to distribute this x and, by multiplying it in, I guess. So, bringing this down, when you foil these two bubbles together, long story short, you're going to get this. So I'm obviously assuming here that you know how to foil by now. So that's what you get, and then by doing that and then okay, so all that, and then of course you got to combine some like terms, but that's what you're going to get. And now I'm going to do one more multiplying, which is going to get me what? X times x squared gets me x to the third. X times x gets me x squared, and then x times -2 will get me that. And I'm done. That's the polynomial function in standard form that would result in those zeros, because it would result in these factors, Number 5. Once again, find the zeros of each function. And we also want to include multiplicity, but I'll say right now, you only need to talk about the multiplicity when we're talking about multiple zeros. If there was just one instance of a certain zero, then you don't need to talk about multiplicity. So here we go. Okay. Now, in order to find the zeros of each function, one thing you can do is factor. And so n set equal to 0. So 5, 6, and those like it. We're going to set it equal to 0 and factor. So 3x cubed plus 21x squared plus 30x. We can start to factor that by, well, what's the first method we always try? GCF. And when you compare all three terms, we see that they have a greatest common factor of 3x. And so what's going to be left over here is going to be an x squared. What's going to be left over here is a 7x. And what's going to be left over here when we divide it out is, I believe, 10. But this can keep factoring, okay? This x squared plus 7x plus 10 can be unfoiled into x plus 5 times x plus 2. And now that it's all factored, now we can set each factor, including the GCF, equal to 0. So 3x would equal 0, or x plus 5 would equal 0, or x plus 2 would equal 0. Now, solving all of these for x is going to be very, very, very simple. Divide both sides by 3. Okay. 0 divided by 3 is 0. Subtract 5 to the other side, or in other words, subtract 5 from both sides. You get that. And then solving for x here, subtracting 2 to both sides. So I get 3 different zeros, and they all have in a way you could say they all have a multiplicity of 1, because I had one instance of this, one instance of this 0, and then one instance of this 0. But you don't have to write any of that. So the 3 zeros are right there. And before I move on to number 6, let me just make a little more room at least. Number 6, here's the beauty of number 6. Number 6 is already showing its factors. So it looks like we have like x minus 2, times x minus 2 times x minus 2 because of this power of 3. Alright? And then we have a factor of x plus 6. We can set all of those factors equal to 0. Like it's going to be, you know, x minus 2 equals 0, or x plus 6 equals 0. Okay, it's very convenient. It's already showing its factors. It's already in factored form. So look, you're going to get a 0 of 2. But there was going to be 3 different bubbles of x minus 2, and you were going to get x equals 2 3 times. And so the one thing you kind of include here is that the 0 of 2 is going to have a multiplicity of 3, because it happened 3 times. And this 0 of negative 6, when you solve for x over there, you could say that has a multiplicity of 1. It occurred once. But you don't actually need to write that. You only need to write the multiplicity thing when it's 2 or more instances of that factor, which means that 0. So, moving on. Now we're back to one where we need to see its factors to find the zeros. Okay, oh, whoa, actually really quick, darn it. On the test, alright, on the test, you are most likely going to have access to a graphing calculator, at least in 2018 here, the year I'm making this video, which the test is going to be in a couple of days. You know, the students in 2018 and hopefully every year following are going to have access to a graphing calculator. So maybe I'll just kind of, or maybe I'll just write this down, because sometimes you can just kind of get out a graphing calculator, graph this function, and on the graph, these zeros will reveal themselves as the x-intercepts. So graphing it, you can just kind of do number 5 that way. Graph it and see that the graph's going to cross the x-axis exactly at 0, exactly at negative 5, and exactly at negative 2. Okay? Number 6, I don't know if that strategy sort of applies since they've already factored it for you. But, you know, I wonder if the graphing method will kind of work for number 7. I mean, I don't know, because I'm going to factor it right now and find the zeros that way. Now this one can be unfoiled, I do believe, but the bubbles are going to start off with x squared, because you have this whole like x to the 4th right here, and x to the 2nd right here. So this is going to be unfoiled, but the bubbles are going to start off with x squared to make it work. And so what two numbers multiply to make negative 16, but they also add up to 6? Let me think about that for a second. That should be plus 8 and minus 2, right? Alright. Okay. And so after we factor, as always, we set both factors, or all the factors, equal to 0. And then we solve. Well, how the heck do we solve this? Well, I suppose we could use the quadratic formula. Same as this, like technically you could use the quadratic formula, but what if we just got x squared by itself and we looked to take the square root of both sides? Now, listen carefully for a second. Whenever you end up doing this whole square root of both sides to solve for x, you're going to have a positive answer and a minus answer, positive and negative answer. So you have this whole plus or minus thing like automatically. Now, how do we do the square root of not only 8, but it's a negative 8? So I guess first, maybe I'll break it down into multiple steps. The fact that it's the square root of a negative, you're going to bring that negative out as the imaginary number I. But guess what? Root 8 simplifies. Okay? Now, I don't think I'm going to actually do a full review of how to simplify square roots. You know, use whatever method you want, but when you simplify root 8, it's going to become, well, if you're doing it, maybe I'll do it a little bit my way. You write it as like root 4 times root 2, because root 4 times root 2 is the same as root 8, and the root 4 just becomes 2. So I don't know why I wrote all that out or said all that, but because the bottom line is it's going to be 2 root 2. Okay, root 8 you need to know is 2 root 2, or you just need to know how to simplify square roots, people. And you put the I right there, so it's like 2 root 2, the I right there. And so these are the zeros from here, and then over here same sort of thing, but a little less ugly. You end up taking the square root of both sides. And again, remember that it's kind of a plus or minus thing. When you're taking the square root of both sides, you're taking the square root of x squared. So what's the square root of 2? Well, it's certainly not a perfect square. Can you simplify root 2? No, you can't. And so guess what? That's it. That's just the final answer. Now, thinking back to, well, could we have just graphed this equation and seen the x-intercepts? Well, I guess, well, let me put my pen down for a second. I guess technically these would show up on the graph, but I don't know if you'd realize that it was exactly the square root of 2 and negative square root of 2. And these are imaginary. These wouldn't show up as x-intercepts at all. So number 7, here's what I'm saying. You can't just have the graphing calculator bail you out of this one. You're going to have to do this number 7 like I just did. You know, because you can't find these two zeros on your graphing calculator. And you really sort of can't for sure see that this is exactly root 2 and negative root 2 on your calculator. So, like, I'm going to want exact answers, I guess is what I'm sort of saying in a way. You can't just approximate these x-intercepts that you see on your graphing calculator. I need exact answers on these problems. So whereas, you know, it wouldn't be that difficult to go on your graphing calculator and see that the x-intercepts for number 5 was exactly 0, and exactly negative 5, and exactly negative 2. But, I don't know. And I guess mainly just because of this reason, you need to do it like all of this. You can't just do number 7 on your graphing calculator. Number 8. Okay. Number 8, same directions, but even though it's the back of the paper, it's same directions. So once again, it's possible you could go on your graphing calculator and look for intercepts, but I don't know, I guess we'll see. I'm going to try to factor this if possible. And it turns out that you got to remember about this situation where you either have a sum of two perfect cubes or a difference of two perfect cubes. Number 8 is a sum of two perfect cubes. Because this would be like your a squared, and this would be like your, this would be like your a cubed, and this would be like your b cubed, which would make a equal to x, and b, right, like what cubed equals 8? And that's 2. And so now that you know a and b in this kind of situation, you go with the formula, which, here's some pretty good news, which you probably already know. You don't have to memorize this formula. I'll give it to you on the test, okay? And so now we look to plug stuff in. And let's see, so we got, look, a plus b, that's going to be a bubble of x plus 2. And then we make a bubble where it says a squared minus ab plus b squared, and so that's going to be what? A squared, which will be x squared, minus a times b, so that's minus 2x, and then plus b squared, 4. Alright? Now look, we want the zeros, and when we factor, it's like we're going to be setting equal to 0. And then again, as always, now we're going to look to set each factor equal to 0. Now this guy, you just subtract 2 from both sides, and that's 1 0. But when you look at this, this can't factor anymore, of course, otherwise we would have done it already. But so what you're sort of forced here is to use the quadratic formula. Now, here's some more good news, I guess. On the test, I'm going to give you a piece of paper with a bunch of pre-solved, what the heck? Alright. Okay, I just needed to wait. Anyway, as I was saying, I'm going to give you a piece of paper with a bunch of examples, like pre-solved quadratic equations with like different a values, and so you won't actually need to use the quadratic formula and go through all that work. It's basically like a reference sheet. So you basically would look at your reference sheet. Okay, let me put it this way. At this point in time, you would look at this and go, oh man, I need to use the quadratic formula. You'd go to the reference sheet, find the correct one where it says a equals 1, b equals -2, and c equals +4, and you would go, oh, okay, there it is. And then you would proceed to just write down simply that x equals 1 plus or minus I√3. And you would kind of find that on the reference sheet and just copy down the final answers. So could you have looked at your graphing calculator? I mean, that would show up on there, right? That would show up on there. But these wouldn't, and so you kind of need to do this factoring type thing maybe, and quadratic formula, but just by looking at the reference sheet. Okay. Number 9. Find the zeros, roots of each function. Once again, if you can factor, you factor. And or go to your graphing calculator. But I'm going to factor, so I'm going to set it equal to 0. As always, set it equal to 0. And I do believe that I'm going to be able to solve this by grouping. I'm going to group those two together. And then I'm going to group those two together. And then I'm going to do, here's the factoring by grouping method. After we do the grouping, now I'm going to do a double GCF. A GCF of each bubble. And so the GCF here is x squared, I do believe. And so I factor that out. And then what's the GCF from the second grouping? 3. And so you factor that out like you should know how to do. And then you see that we had repeat bubbles of x minus 2. And so that comes out. And then another bubble, you put x squared plus 3 in. And there's the answer from factoring by grouping. And like always, after you factor, you set each factor equal to 0. This one, piece of cake, solve for x. This one, you would subtract 3, and you'd end up with x squared equals negative 3. And so when you take the square root of both sides, okay, you have this negative in here, which is going to come out as an I. Oops. Don't forget the whole plus or minus. And then after we bring out an I, because the negative, can we simplify root 3? No. And so could you have graphed this and seen the x-intercepts? Well, you would have saw that one, but not those, and so this factoring is one of the actual options you need to kind of choose to get these zeros. Okay. Oh, number 10. Number 10. Same directions. Find the zeros / roots of each function. Well, look. All this time, you should have been looking to try setting equal to 0 and factoring, Because who knows if the graphing calculator was going to tell you like all of the actual zeros, because there was a lot of imaginary zeros, a lot of like irrational zeros with square roots. So you never know if your graphing calculator is going to be able to show you all the zeros as clear as you want. So we were always like going to set equal to 0 and factor. Well, if you were to try to factor this, all of the different methods we know of, you'd kind of run into a dead end. You might look at this and go, oh, I think this can factor by grouping because there's like 4 terms and stuff. Well, just trust me, you'd run into a dead end. You'd run into a dead end. So, here's what we have to do. We learned in class that you could take factors of 3, plus or minus 1, plus or minus 3, and then factors of the leading coefficient 2, which is plus or minus 2 and plus or minus of 1. And you could put you could kind of mix and match factors of this in a numerator and factors of this in a denominator. And those would be all of the possible zeros. And therefore, you could figure out possible factors and kind of like go from there, Well, here's what I'm going to recommend you do. Take this function, graph it, okay, and look at the x-intercepts. And let's find one of the rational, okay, which in other words, nice. Like, let's find one of the nice, rational, clean zeros from the graph, rather than mixing and matching factors of this in numerator and factors in. Let's just look at the graph. So here's the graph you would kind of see. And when we look at what these values are, see right there? That is exactly 1. So one of the zeros was 1. In other words, one of the bubbles was x minus 1. That's one of the factors. So using that, okay, that one of the bubbles is x minus 1, one of the zeros is 1, I'm going to do a little synthetic division oops, I didn't need to write a plus 3, did I? Just 3. Alright, so again, I know from my graph that one of the zeros is just 1, which means one of the bubble factors is x minus 1. I'm going to divide this away from that and get like another factor as a result after the division. And so by synthetic division, here's what happens. I bring down the 2. And now I multiply 1 times 2, which is 2, and I write it there. Now I add those together, and then I rinse and repeat. I do 1 times 6 to be 6, and put it right there. Now I add vertically, and I get negative 3, and now I do 1 times negative 3 to get negative 3, and I add those, and I get 0. And so what this result means, you know, since this is like my remainder, this is like my constant, that's like my x term, and that's my x squared term, that means that the answer is 2x squared plus 6x minus 3. And so I could say that Alright, now, to find the zeros, we're going to set both of these factors equal to 0. When I set this equal to 0, we already know we're going to get x equals 1. We already knew that. When I set this equal to 0, it can't factor, and so we go with our quadratic formula. And at this point, you would go to your reference sheet, all right? You'd go to your reference sheet, and you'd find the one where it says a equals 2, b equals 6, c equals negative 3, and you would just look at your reference sheet and copy down how the answers from this guy being set equal to 0 are negative 3 plus or minus root 15 all over 2. Alright. And the last one. This one wants you to write a polynomial, well, fourth degree, but they want you to write a polynomial equation with integer coefficients that have the given numbers as roots. Okay, first and foremost, if one of the roots is root 3, okay, remember, irrational roots and complex roots always occur in conjugate pairs. So if these two guys are roots, then so are these. And so that leads you to be able to write the factors to start. Okay, so if root 3 is a 0, then x minus root 3 is a bubble. And then if negative root 3 Okay? So on and so forth. Now, if 1 minus I is a 0, then x minus that is a bubble. And then if that is a 0, then x minus that is a bubble. Okay? So here's what I'm going to do to kind of proceed here, because when they say, you know, write it out with integer coefficients and stuff, you're just going to have to now multiply all of this together. But here's how we're going to do it. I'm going to FOIL these two bubbles together, and then I'm going to work on these two bubbles being multiplied together, and we'll kind of go from there. So here we go. You know, doing like x and that. So we're going to have x squared. It's going to be a plus root 3x, but then it's going to be a minus root 3x. And those are going to cancel out. So I could write down, well, I'll write it down. Plus root 3x minus root 3x. And then when we multiply the negative root 3 times the positive root 3, we're going to get minus 3. Now over here, I think I'm just going to kind of clean this up a little bit. Like distribute that minus and get x minus 1 plus I. And then over here, x minus 1 minus I. Just to kind of clean that up. So continuing to clean up, let me change colors. All right. Now, to start to multiply these bubbles together, it's not that big of a deal. We're just going to do like x times x, x times negative 1, x times negative I. So we had to distribute the x. Then I'm going to distribute the negative 1, negative 1 to here, negative 1 to here, negative 1 to here. And then finally I'm going to have to also distribute the I times this, I times that, I times that. So what I'm really going to do. So x times x is x squared, x times negative x, and negative ix. So that's what I got, distributing the x. Now I got to distribute the negative 1. Negative x plus 1 plus I. So okay, so I just distributed that. Now I got to distribute the I. Plus ix minus 1I minus I squared. All right. Now looking to clean this up a little bit. This and this are going to cancel out. This and this are going to cancel out. Will anything combine? So no, x squared, nothing combines. Negative x and negative x. So minus 2x. Okay. That's gone. That's gone, that's gone. Well, I want you to remember something, that I squared equals negative 1. You're going to have to remember that. I squared equals negative 1. And so what this becomes is minus a negative 1. So it's really plus 1. So this and this are going to combine together into plus 2. All right? And so now I just have to keep multiplying all this stuff together by distributing, let's say it's going to be x squared through these three. Then it'll be a minus 3 that I distribute through these three. So here we go. X squared times x squared, x to the fourth, x squared minus 2x cubed plus 2x squared. And so that takes care of that. And now I have to distribute the negative 3 through all this bubble. So minus 3x squared plus 6x minus 6, right? Plus 6x. Alright, and so now I can write my final answer by combining like terms. Nothing combines with that. Those are the... Oh, wait, I thought that was a cubed. I could have swore that was a cubed, but it was not. So, redo. So does anything so nothing combines with that. Alright, so nothing actually combined with that. Sorry. It's these two that combine, because that's a power of 2, that's a power of 2, so minus, so let's say 2x squared minus 3x squared is minus 1x squared, and then we can bring those two down as nothing combined with it. And that's number 11.